Hello, and welcome to the equation to graph with tangents of their transformed functions. I'm hoping that the last video that you watched was about the tangent parent function. It looks much more interesting than sine or cosine, in my personal opinion, but the transformations are really similar. So if we're just writing down the transformed version of the function, that's going to be f of theta is equal to a times, in this case, tangent, but it could be sine, could be cosine, of some b value times theta minus h, close all those parentheses, plus k. So again, a, b, h, and k mean all the same things that they have meant throughout our past dealings with transformations. If you want like the really specific information, that can all be found in the transformed video for sine and cosine. But I just want to mention really quickly the b value here. That is going to be our frequency. And again, frequency is how many periods you have in a specific interval. So when we're looking at tangent, that specific interval is going to be pi. So if I want to find the period, I can say, hey, I'm going to take that interval of pi and divide it by the frequency, or how many of those periods we're going to have. So remember, the frequency is in the equation. So if I ask you to find the period, you're going to need that b value. Or if we are, for instance, looking at the graph and I want to find the frequency, I'm going to do pi divided by whatever I see as the period, or how long it takes the graph to repeat itself. In the example I'm going to be doing in just a moment, I'm not actually going to have a b value, or I'll just have a b value of 1. I think we'll deal with that a little bit more in class. But let's get to it. So we're just going to do one example of transformations because I feel like we've been practicing that a lot. So let's do f of theta is equal to 2 times tangent of theta minus pi over 2 minus 1. So in this case, you may not need those square brackets just because we don't really have a b value, but I like to put those in there just for practice. So let's take a look at our transformations. Again, we have no b value, but we do have an h, or a horizontal shift. So that is going to be a horizontal, or h, shift to the right by pi over 2. And that's all the horizontal or x value things we have going on. So let's take a look at our y value, or our vertical changes. So right here, this 2 on the outside, that is going to be a vertical stretch by a factor of 2. And then all the way to the right, you're going to see that -1, or a vertical shift down 1 unit. So let's do all this let's take all this and have it affect our parent table. So just a reminder about our parent table. I'll make this a little bit big. So we are dealing with the x values of negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. So again, slightly different than sine and cosine. And our y values for these, at the negative pi over 2 and pi over 2, we had asymptotes. So we're going to say that's undefined. I'm going to just write UNDEF for short. So we use those for undefined. And then for when the x is negative pi over 4, our y value is -1. At 0, our y value is 0. And when x is pi over 4, our y value is a positive 1. Redo that y value. There we go. So again, this all comes directly from the unit circle. Spend some time with your unit circle. Make sure that you know those shenanigans. Anyway, let's start with our horizontal stuff. So for our horizontal stuff, we're going to add pi over 2, since we're moving pi over 2 to the right. So that's going to bring us to 0, pi over 4, pi over, 2, there we go, 3 pi over 4, and pi. So some of these I am getting from kind of preemptively changing my denominator So especially here with the pi over 4 plus pi over 2, pi over 2 is the same as 2 pi over 4, so that's how we got 3 pi over 4. So you don't have to show me that work, although if you want to do it on the side, that is perfectly fine. But that's what we have for our new x values. Now for our y values, we're going to take all of our y values and multiply them by 2, and then subtract 1. The cool thing is, if I take anything that's undefined, or like an asymptote, and I try to do anything to it, nothing really happens. It just stays an asymptote or undefined. So if I take something that's undefined and multiply it by 2, it's still undefined. Then we have -2, 0, +2, and undefined. And then if I take something undefined and I subtract 1, it's still just undefined. So this will stay undefined, and then we'll have a -3, -1, +1, and still undefined. So these are our new x values. These are our new y values. Let's get to graphing. Feel free to, again, pause here. I'm going to move this up just a little bit. Feel free to pause here. I'm going to pause and do the scaling. We'll see how that goes. So here you can see I have scaled everything. Again, feel free to pause. You can see I have on my y-axis more area in the negative space because we have more negative y values, but my x-axis is still scaled by pi over 4, but only marking up every pi over 2. So let's get our points / asymptotes graphed and see where we can go from there. So first I see that at 0, we have something undefined. So that's going to mean an asymptote for us. So let's do that here. Please make sure to actually mark up your asymptotes. They're denoted by a dashed line. Let's see. Next, we're going to have, pi over 4, -3. We have pi over 2, -1. We have 3 pi over 4, +1. And then we have another asymptote or something undefined at pi. It's right here. So what we get is again, something that looks like a cubic function, but that's been stretched out a little bit. If you go back and you take a look at the parent function of tangent, oops, there we go. You will remember that or I guess you're going to take a look over here. You have -1, 0, and 1. So that would just kind of be all here, all within very, very close to each other. But now we're going twice as tall, so it looks a little bit more stretched out. We can say that, hey, our period didn't change. We didn't have anything stretch or compression happen horizontally, so our period is still just pi. So we can continue with this pattern and go every asymptote, every pi, and get the same thing. So if we have asymptote, -3, -1, 1, asymptote, we can continue that. So if we continue that in the positive direction, we already have our asymptote at pi, then we're going to have -3, -1, 1, and then another asymptote. Make sure to connect all your points. Notice that when I'm doing it, I start at the middle. This helps kind of keep everything nice and curvy. Notice I'm also putting arrows at the end, and I'm making sure it goes up against the asymptote. I'm trying to draw it as kind of tall as possible. And then we're going to do the same thing but backwards. I know I've already drawn a few periods, but I want to make sure I always complete my graph from -2 pi to 2 pi. So now if we're going backwards, that's going to be, I keep doing that, asymptote 1, -1, -3. So here we have asymptote, and then we'll have 1, oop, that is 2, that's the wrong thing. There we go, 1, -1, -3, asymptote. We can get all that connected. And then again, we have our asymptote, and then +1, +1, -1, -3, and asymptote. So there you have it. This is a transformed version of tangent. Again, just be careful with your asymptotes, making sure that you're drawing everything from one end of the graph to the other. As of right now, when we're working on homework, feel free to check your graphs on Desmos. But we'll just be practicing some more of this tomorrow. Let me know if you have any questions. I look forward to seeing you then.